I'm going to talk about admission control. The basics of admission control are that it prevents the creation of universal circuits if the network can't handle the traffic. An example of this is if you have a telephone switch and it's overloaded, it won't give you a dial tone. So in order to do admission control, we need to figure out what the traffic is actually doing. And for that, we have two different properties that we look at. We look at the rate, the frequency of the traffic, and the shape of it. So how big is the traffic? How big are the packets? So first example is web traffic, and that's called bursty traffic because it's large in the shape and Alright, so it's large in shape because the entire page is sent at once. The second example is video, which is a higher rate traffic, which means that you have a large amount of data being sent over a large amount of time. So in terms of division before the need virtual circuits, a fair division is really ideal. We don't want to have a 100 megabit circuit be divided into equal 10 megabit parts. So in order to figure out which circuits can be bigger, we do traffic aware routing, which means we look at the traffic that's being sent over the circuits and we adjust the sizes accordingly. Next up is traffic throttling. The base of traffic throttling is that we operate the networks just before the onset of congestion. If there is congestion, we tell the network to slow down the transmissions so the network can catch up. The first method of doing this is called explicit congestion notification, ECN, where we tag packets with header bits that tell if there's collision or not. It goes all the way to the destination first, and then the destination will reply to the sender. It tells the sender that there's congestion and to slow down the transmission. In the image, you can see the marked packets being sent from the congested router. The destination gets the marked packet and then sends back a signal to the host to the source, showing that there's congestion. The next method is called choke packets, which is the most direct way of notifying the sender. Choke packets are new packets that are created by the router and sent back to the source. So the source can be told directly that it needs to slow down. They're sent at low rates to basically not congest the network anymore than it already is. And the time to send is determined by a formula which is called exponentially weighted moving average. So that's the formula. You can read that. It's basically an equation to determine if the router is congested or not by having a threshold. And if the equation result meets the threshold, then it starts sending choke packets. The next method is called hop-by-hop back pressure, which is like a choke packet, but it takes effect at each hop it passes. So in the image, you can see that on this side is the standard choke packet path, and on this is the hop-by-hop path. You can see it's shorter because it takes effect at each different point that it passes here. In order to use hop-by-hop back pressure, you need to have routers upstream that have more buffer space so they can hold more packets in while the other routers get relief. And finally, load shedding, which sheds the network of packets. It uses two methods to determine which packets to shed. There's wine and there's milk. So wine means that older packets are more important than newer packets. For instance, in file transfer, where you want to keep older packets so the receiving end can start building the file up rather than saving the packets they can't use. And in Milk, there's newer packets that are worth more. So like real-time media, where you want to have the newest packet be pushed to the front, we don't really care about the old packets. So in both of these, the application marks packets that are either wine or milk, and the routers can crash the ones that don't fall into that category.
So what's load shedding? Does anyone tell us what load shedding is? Go ahead.
Okay, that's when you figure out which packets you want to get rid of to get rid of the load.
Yeah, that's right. So do you want fortune cookie or Red Bull?
No.
All right.
Hey, can someone from my team have pizza?
Yeah, that's fine.
Who wants pizza? You want to have pizza?
Yes, you can. You can come get your pizza.
Do a shot of Red Bull.
And you can do a shot of Red Bull for everybody.
No. No one wants pizza?
No, we're good.
Okay.
You want it?
Hey, someone else can have mine.
Okay. Anyone that wants can have some. So.
Anyway, the last method of admission control is called random early detection, where routers use the TCP handling of drop packets of assigned congestion. It uses that as a way to slow down the transmission rates.
Continue. It's alright. Accidents have to happen after you.
So like choke packets, the moving average is determined by that equation. If it exceeds the threshold, it starts random early detection by dropping packets. The sender would notice the drop, and the TCP protocol would kick in and start retransmitting the packets and slowing down the transmission. You need to tune the threshold for this to work properly, or for it to work well.